Today, we get to have a deep dive interview with one of the leading humanoid general purpose robot manufacturers. But this one is different. Sanctuary views humanoid robots as a means to an end, where the end is human-like general intelligence. Our guest today will share more about their Phoenix humanoid, but also about AI, AGI, and alignment with human values. Sanctuary AI was founded in 2018 by some of the people who founded D-Wave, a developer of quantum computers, and Kindred, the first company to use reinforcement learning in a production robot. Sanctuary AI was the first company to deploy humanoid robots in a commercial setting last year. Their robots were capable of performing hundreds of tasks on site at one of the biggest retailers in Canada. Suzanne Gildert is Chief Technology Officer and has been a prominent figure in AI robotics, leading to her being often affectionately known as the mother of Embodied AGI. While at D-Wave, Suzanne invented the world's first game ever played against a quantum computer and was the first person to control the motion of a robot using a quantum computer. Joining me on the second half of this interview will be Dr. Scott Walter, a two-time co-founder of industrial robot companies. Suzanne, lots of firsts there. Welcome and thank you for joining me.
Well, thanks for having me. This is a really great opportunity.
I really appreciate everything you're doing. And you have been in robotics for a long time. And what I love about what's different about you and Sanctuary is that you aren't just doing the humanoid bots and the physical bots, but you've been working on AGI, and we'll talk about quantum mechanics quantum computing that you've done as well. So let's get right to that, right? The first question would be, you guys are focused on human-like intelligence in a general purpose robots. Tell me about, this concept of embodied AI that leads to AGI. It sounds like that you guys are a believer that that's what's necessary. Tell me about your thinking about that.
So the reason that I'm really interested in this is I'm fascinated by the human mind. So this is not just about technology and science. Every single one of us has this thing we carry around, which is our brain and our mind. So how we think, how we feel, the emotions that we have, all this stuff is so interesting. And if there's a way we can bring technology to bear on that problem of really understanding who we are as humans, I think we should try that. So I got really interested in the AI side of things and how we might build minds. And then it turns out that in order to understand minds like ours, they were evolved to control bodies. So putting AI minds into robots seems like a really natural way of starting to explore what the mind is scientifically. So I'm really coming at this as a scientific question of who are we? What is this thing we think of when we look someone in the eyes and we see their mind and their consciousness? What is going on in there? That's what I'm interested in.
Yeah, no, I love that. So it sounds like you're kind of like mind first and then hardware second.
Yeah.
So how are you building this? How are you measuring to see if you're having success in this?
So the initial sort of founding idea of this, going right back to, I think it's 2012 or 2013 when I first started thinking about these ideas. I actually read a book a few years earlier called On Intelligence by Jeff Hawkins, which was very transformational in my life. It's the first time I read a book where I thought maybe the brain is more like an algorithm than this kind of like squishy, wet biological structure that we're used to thinking about. So I was inspired a lot by those ideas. And I was thinking in particular of some of the ideas in those books where Hawkins talked about the brain as being a prediction device. So it predicts what you're going to see, it predicts what you're going to hear, and it predicts how you're going to move. So the thing is about that is if you want to start exploring how systems move, then you need some kind of body for them to move. And that's when I started thinking together with some colleagues about the idea of combining some of these new AI predictive model ideas with robotics and robot bodies.
And then what are you finding about embodied AI? Is it important to be embodied AI versus just an LLM and a computer that will then get to AGI? Do you guys feel strongly that embodied is going to be the leading, that's going to be what takes you to that path?
I feel that very strongly because to me, if you want to just build intelligence in general, I don't think you need a body. But if you want to build human-like intelligence, something that's like us, it needs to be put in a body. Because a lot of the way we understand the world is through how we interact with it, how our body moves in the world, how we touch things, how we interact with objects. It's all kind of like body-centric or ego-centric, as we call it. So having a body allows an AI to really learn about the world in the same way we do and experience the world in the same way we do. So I think not just a body, but a human-like body is absolutely critical if you want to develop something that's a human-like AI mind.
Okay, good. Let's talk about Phoenix, which is your 6th generation humanoid. You've got Carbon, which is, I guess, the brains and the intelligence on it. And I saw that you said Carbon mimics subsystems in the brain: memory, sight, sound, and touch. I'm going to go ahead and play video, but tell me more about Phoenix and what we're watching. And is it working autonomously? There's going to be a whole conversation about teleoperation. And I know that teleoperation is very critical to teaching it to eventually be autonomous. But tell me more about Phoenix, where you're at with this.
Mm-hmm. Yeah, so Phoenix is a work in progress. It's, as you mentioned, a 6th generation robot. So there's been 5 variants of this before we got to this point, and there'll be many future variants of this system. So it's obviously a humanoid robot. It has about 60 degrees of freedom in the robot, which means there are 60 different joints that can move. A lot of those are in the hand. So Phoenix has very dextrous hands for doing fine object manipulation, which is very interesting because a lot of the human mind evolved so we could use our hands to interact with the environment. So we've focused quite heavily on the hands and the dexterous manipulation. So this version of Phoenix is designed to do dexterous manipulation, kind of add a bench in front of it. It can move around, but we don't focus on that as much. A lot of people are focusing on making the robot walk before it can manipulate objects. We've kind of taken the alternate path where we started with dexterous manipulation of objects on the benchtop and then making the robot more and more mobile over time. So the control system that controls this robot is called Carbon. It's a software system. And the best way to explain Carbon is that it has three modes of operation. So the first mode is what you're seeing here. We teleoperate the robot. You can actually see that it has a light on its chest plate, and the color of the light indicates which mode it's in. So you're seeing it in this teleoperation mode, also called data collection mode. When a person takes control of the robot, they move the robot around using exosuit rig technology. And the reason we do this is so that we can make sure the robot's capable of doing things and also collect data on those tasks. And then once the data is collected, you can then run it in one of 2 other modes. There's a single purpose AI mode and a multi-purpose AI mode. I'm sure we'll get more into those a bit later on. So yeah, it's a bit of an overview of the Phoenix and the Carbon system.
Okay, no, wonderful. Why don't we talk about that? So tell me about training. So I think there's, like you just said, there's simulation, there's teleoperation. So how are you training this, and when have you been able to do, having the Phoenix be able to do working autonomously? And then, from there, when do you see useful work?
Yeah, it's a really good question. So what you were seeing in that video was the kind of the data collection side of it. So we run these robots now several hours every single day in this data collection mode. So we're amassing this giant, what we call data lake of many, many, many different tasks. And the interesting thing about our approach, which I think is differentiated to many approaches, is we're not necessarily trying to automate tasks one by one, if that makes sense. We're trying to automate foundational building blocks of all work. So let me give you an example. So a task might be going to a retail store and take items off a cart and then stack them all on a shelf. So that's an example of a task. You might try to automate that. An example of a foundational building block might be grasp an object. It might be rotate an object in your hand. It might be place an object on a surface. So our approach is different because we're trying to create this library of building blocks from which we can use those. We can put them together in different ways to automate all work rather than automating work tasks one by one. So again, it's a little bit of a mind shift to wrap your head around, but I like to think of an analogy as being the alphabet. So imagine you learn every single letter in the alphabet when you're a kid. You can now use those letters, put them together in different orders, and you can write Shakespeare. You can write any novel you want now. So if you've learned those fundamental building blocks of movement and of action, you can now put them together in different ways to do all work. So it's a little bit of a mind shift to think about automation in this way. And that's why we haven't shown many examples of these full tasks being automated end to end yet, because we're still learning the building blocks.
Okay. And then to what extent do you use teleoperation or simulation, or what the other, I think you call it what do you call it? You say it's like, world models, inner world models, and perception and motion planning. Walk me through all that.
Yeah, so there's actually a ton of different ways you can do automation. So the way that we did it in 2022 and early 2023 was that we looked at what was called a modular cognitive architecture approach. So this was using some more classical AI tools, which were optimization-based motion planning. If any of your audience is very technical, want to know more about that. So we were looking at building like these modular AI pieces for perception, for movement, and for building what's called an inner world model, which is like a mental model of what's going on around the robot. So you can actually build an AI system by creating these modular pieces, and like language was another one, and memory and emotion and all these other things. So that's a really cool approach, and we're still doing that. But what we've done in later 2023 and now into 2024 is we're focusing down on a very particular module within that. And that, if anyone's familiar with the brain, we have the motor memory and the cerebellum, which is like your motor control system. So this is a thing that takes a thought in your mind and turns it into motor action in your body. And the way that we train that part is we collect a lot of data of the robot doing these little building blocks of movement. So, for example, we might collect 1,000 what's called episodes, training episodes of a human pilot in the teleoperation rig, just picking up an object like a metal cylinder and moving it from one place to another, picking it up and moving it, picking it up and moving it. And so this is now called a data-driven AI training approach. It's also sometimes called behavior cloning or imitation learning in the literature. And what you're doing there is you're kind of programming in these little procedural muscle memory movements into the AI so that it can then use those as part of a wider cognitive architecture to move its body.
I know, I'm following along. Okay, so it sounds like your focus was mind first, right? That your background, your CEO's background was in quantum computing. You are really focused on the AGI component. You needed to be embodied AI. The second thing you guys doing is hands first approach is also what I've seen, right? So you are very focused on a tactile. You bought some IP. You took the IP from Giant AI. I actually was very familiar with Giant AI. Robert Scoble did a interview with their CEO a long time ago, and they were the ones, very early on, right? And you took that IP. So tell me about what you've done with the hands and fingers. Scott and I, he'll join us shortly. He and I very much believe that you need to have very dexterous fingers, tactile, feeling, all that, and proprioception, whatever. So tell me more about how that, why that's important. Yeah.
Proprioception.
Thank you.
Yeah, tricky. I know it's tricky word. So we've taken a very hand-first approach, and the reason is that no one's really been able to make any kind of engineered robot hand yet that's anywhere close to how good the human hand is. The human hand is a marvel of biological engineering. So we've tried to get as close to it as possible. So our hand actually has 16 degrees of freedom in it in each hand. So it's actually quite close to the way that the real human hand works. And as you mentioned, we acquired some assets from Giants. We actually really liked their approach. They were using what's called visual servoing. So this is when the robot's able to look at its own hand and figure out what its fingers are doing through by looking at it through its vision system. So the reason this is important is because you don't necessarily always have fully accurate information coming back from any one sensor. So if you have a sensor in a finger that's telling you where the finger is, or you have a haptic sensor, those sensors might not be accurate individually, but when you put all those sensors together and you combine them with vision information as well, you can actually get more of an accurate representation of where your hand is. So Giant had some really interesting IP around this concept of using vision in the loop, sort of watching what your hands are doing and where they are. Of course, that gets you so far. It's when you're able to see what you're doing with your hand, you can use that kind of technology. It works really well. But the Phoenix robot also has very advanced haptic sensors on its fingertips as well. So it can even do things without being able to see the hand. So you can imagine this if you had to feel inside your bag to find your keys. You can't really see what you're doing at that point. You have to rely on different sensory information coming from your body. So we've actually invested quite a lot in making these haptic sensors, improving haptic sensors on the fingertips of the robot so it can feel its way around the world when it's doing dextrous manipulation as well. And all in all, we're really trying to build the world's best robot hand, because hands are where our mind meets the world of work. Mm-hmm. You know, in order to believe, if you don't believe this, just spend 10 minutes or maybe even 5 minutes in your morning routine and just very mindfully pay attention to what you're doing. Almost every single thing you're doing involves your hands touching something. You know, you're turning on the faucet to make a cup of coffee, you're pressing a light switch, you're opening a cupboard door, you're like washing your face, whatever. You're using your hands constantly all the time. So whilst mobility and bipedal walking is absolutely important and it's on our roadmap, that ability of getting the hands to the work is where we wanted to focus initially.
Okay. No, I'm loving all this. I love it. I'm buying into it. So mind first, hands first. So I'm just going to ask you a few questions on your business model. So first of all, it sounds like you guys are an AI company. Do you see yourself partnering with, OpenAI, DeepMind, some of the other players in that field?
Yeah, so I can't mention any specifics, but we are actually very open to working with others. I think it's one of the things that differentiates us. We realize that this is a huge problem, and I don't think any one company is going to solve this problem end to end. You absolutely need to partner with others out there, whether it's from the academic establishments, whether it's from big tech companies, or even other startups. So we're very open to working with others and looking at consortium models for this, because this, honestly, I have to say, this problem, like building human-like intelligence in robots, is a civilizational scale problem. Yeah. This is one of the biggest technology challenges and opportunities we've ever had as a human race. So I think we should work together wherever we can to really drive this forward, and also to have more voices and input on how this technology is going to be used safely in the world as it goes out there. We don't want, say, one person controlling and making decisions about how this technology is going to go out there and impact society. We want lots and lots of different diverse voices talking about this. So yeah, absolutely.
Perfect. Wonderful. Yeah, Scott and I and a few others have started a think tank called Foundation, and it's going to bring together folks like you and others to talk about the impact to society, because like you said, it's probably the most significant, benefit or harm to society, but more likely benefit. So let me ask you about, in my intro, I talked about how you actually, went into one of the largest supermarkets and retailers in Canada. Do you have customers coming on board soon, or partnerships maybe that you can talk about?
Yeah, we do have some customers and partners in the works. I can't give you any specific names at the moment, but I can give you some general ideas of what those categories are. So retail is one of them. Manufacturing is another big focus for us. So assembly and manufacturing. And I think at this point, what I wanted to mention, because a lot of people do worry about the impact of robotics and automation on labor, but there's actually millions of unfilled positions in the US. So one of the things that we've always said from the beginning is we absolutely don't want robots taking people's jobs. That's not the idea here. What we want to do is build systems that can fill positions that cannot be filled. So there are parts of the infrastructure and the economy that are crumbling because we're not able to hire people to do the work. Either there aren't enough people that live in that area, or the working conditions, just no one wants to do that job. So there are some really interesting and critical areas in manufacturing, especially where this is the case. But the other thing I like to think about these robots is, okay, there's a whole bunch of dull, dirty, dangerous jobs that we can do in the short term with robots that will actually improve working conditions for people. But then in the future, imagine if these systems can actually do new jobs that don't even exist today. So one of the things I like to think about is robots going into space for us. So people are talking about in the future, mining asteroids, going to other planets, this kind of thing. We do not want to be sending people to do those kind of jobs. We want to be sending robots. So I'm really interested in expanding the entire pie of the economy of kind of work we could do here. Don't think of it as a zero-sum game where there's a certain number of jobs and either people are going to do them or robots are going to do them. Think of actually expanding the entire economy so that we can do jobs that may not be able to be done by people.
Yeah, lots of opportunities. And I think also, would you agree that every robot humanoid manufacturer who creates robots, as long as you can pass, you need funding, you need the brains, you need to be able to manufacture this, but you're not going to, there's going to be so much opportunities for everybody, right? There's going to be just so many, like you said, unmet needs, correct? Yeah.
Absolutely. Yeah. And I think I actually see robots in the future will be expanding the kind of work we do, expanding the economy, not just doing the kind of things that we see being done now.
What's your plans for manufacturing then? Like, so your head in some places, you're working on the brain, you're working on the hands, you're making sure that you can do useful work. When do you plan to do mass manufacturing? Like, when will you see 100 of them in your, produce 100? When will you see 1,000? When will you see more?
Mm-hmm. That's a really interesting question to answer, because I think one of the things we have to consider is that the AI and the robotic hardware systems are very tightly coupled together. And there are still a lot of open questions in this AI research. So really the point at which you decide to scale and go to mass manufacturing, in my mind, depends on how well the AI is doing. So if your AI system is starting to be able to learn from data, and you're starting to show that you can automate not just single purpose small things, but actually general purpose tasks, then you know that your hardware is sort of ready, if that makes sense. At that point, you want to start scaling. So anyone that's talking about scaling today and manufacturing large numbers of robots, I would be very cautious about doing that, because what you're saying is you're sure that the data you're getting from these systems is good enough that they're going to solve the AI problem. Now, if they are, then that's great, but there's a trap you can fall into of scaling too early. So this is what we're really trying to avoid. If you show, say, some single purpose task being automated, and you're like, this is great, now we can scale, and you build a fleet of 10,000, 100,000 robots, sure, they're going to be able to automate that one single purpose task. But then it's not clear that you can go from there to something that's general purpose. You might end up painting yourself into a corner. So we're going very slowly and cautiously here. What we want to do first is identify the customer demand that we have and build units in numbers that satisfies that initial demand, those initial proof of concept projects that we're getting. Because no one in the world is ready to adopt mass numbers of robots yet. Let's be real here. It's not going to happen. These contracts that you might be hearing about, these are small test things. These are large corporations getting interested in this space. It's usually their innovation groups. They're going to be saying, let's get 2-3 robots, maybe 10 max. Let's try it out. So the kind of contracts that everyone in this space is going to be getting are going to be low numbers of robots to start with. And so we plan on fulfilling those purchase orders and then working very closely together with customers to see if we can automate their primary task, but then also make sure that the system generalizes so we can look at other tasks in their environments at the same time.
Okay. What do you say to those people who believe that, you might need 1,000 robots because it's that you need that many out there with vision, perception, and then they all teaching each other, that you need that amount. You can't just do 10s, 20s. You got to actually get out there and get that data to collect, to understand the real world. At least 1,000?
Yeah, so this is absolutely brilliant question. And this is a total catch-22 situation when you're working in this field. So ideal, you would want thousands of robots to be able to collect enough data to automate everything you want to automate. The problem with that is, as I mentioned, you don't know whether you can do it yet until you've built 1,000 of them. And at that point, if you can't, then you've got stuck. So this has been a big problem in robotics forever. How do you solve this problem? You solve this problem by going to simulation. So if you can simulate the robot that you want to build 1,000 of first, and the simulation is good enough, you can show that your AI is going to work. You can show that the task is going to be automated before you build the robots. So I think this is really, really important point here, is that before you go all in and scaling on manufacturing a general purpose robot, you absolutely need to solve this, what's called sim to real gap in simulation. So you need to show that you can build a simulation of a complex general purpose robot, that the AI works on it and you can automate in simulation, and then that simulation transfers over to your small number of prototypes. At that point, you're then ready to scale the hardware. So hopefully that makes a bit more sense. And with simulation, you can get the kind of volumes of data that you actually need to show that the AI is going to work.
Okay. And so what's your time frame? Like, give us an idea here. Are we talking, you're here today. What's your guess of where you'll be next year, 2 years, 3 years? What should we expect from not only you guys, but also other humanoid robots?
Yeah. So maybe I can start with the wider timeline. So I'm absolutely convinced and I have conviction that by 2030 we're going to be seeing millions of humanoid robots out there. So that would be my prediction. So I'm kind of like putting a pin in the map in the long-term future here. So let's say million by 2030, if not more. So like that gives us 7 years. Now, what are we going to do in those 7 years? Well, it happens to be 6 zeros, so maybe we can exponentially scale it by a power of 10 every year. I actually suspect that's going to be what happens. So I think over the course of 2024, and I'm not just talking about us, but other efforts as well, I think we're going to start seeing robots in the tens or so going out there in the world, being used in these, what I would call proof of concept innovation projects, a bit like what we did with our deploy last year. So we actually deployed 2 of our humanoid general purpose robots into the wild in the field, actually doing work in retail stores. So I believe that was world first. And I think we'll see that kind of system, that kind of project being replicated. So we'll see these low volume numbers, like less than 10, going out there being used as proof of concepts for a year or 2. And then after that, we'll start, I believe we'll start going into the hundreds. So we'll start going into the low volume contract manufacturing phase, where there's multiple customers being served. Customers are now issuing purchase orders for hundreds or thousands of units. And then you have to then go to your another level if you want your mass manufacturing scale.
Great. Okay. Thank you so much, Suzanne. I'm going to add Scott Walter to the conversation. He and I have done many of these videos as well. Yeah, Scott.
Hello, Suzanne. Yeah, it's a pleasure to be here. And it was great listening to you. Yes, same here. And that's you answered like a lot of the questions and of course created a lot more for me.
Okay.
One of the first questions I had, because I'd gone through and seen some of the things on your website referring to visual servoing. And I was kind of curious what that was. And you helped kind of close the loop where I've always felt that you could almost get away without any sort of sensors, maybe just like back EMF in the vision system to get enough. But when your hand is hidden, it's nice to have that. And we've seen like other companies take 2 different approaches on here. Tesla started out without it because they thought back EMF was going to be enough. And now we've seen the latest generation, they decided to put the sensors in. Figure started out with it and are saying that it looks like we don't need it. So what is kind of your thoughts on that? Because we're seeing that they're all getting kind of conflicting signals of what's going on. Would you like to take that on?
Mm-hmm. Oh, Scott, I have the full answer for you here.
Okay, great.
So from our perspective, it's actually very, very simple to answer this question. So we're just trying to build something that's as human-like as possible, because we believe that evolution worked for billions of years to create our body and our sensorium to be just so for interacting with the environment that we're in. So our approach has always been try and replicate the human sensorium as closely as possible, and you will have a system that is the best suited for general purpose work. So again, it's related to this trap I was talking about that I think people can fall into. So if someone's trying to automate a task and then they're like, oh, we could make a simpler robot that can still automate this task and it doesn't need haptics because it can see its hand. Let's take the haptic sensors off. So that's absolutely fine. But what you've done now is you've painted yourself into a corner because you can't use the same system now for a general task where it can't see its hand. So our philosophy from the start has always been, don't think about the specific task you're trying to automate. That's where you get stuck. you have to think about trying to make something that is faithful to the human form, similar senses, similar ways of moving. And then you have faith in the fact that something like that will be a general purpose intelligence and a general purpose system in the world. So this is kind of very simple for us. I know some people probably agonize over this question, but to us, it's just make it as human-like as possible, give it the same senses that people have as well as we can build that in, and that you will have a general purpose system at the end of the day if you do that.
Okay. Yeah. Now I agree with you that our brains and our hands co-evolved, which is why it's sort of important to close that loop. And when you sort of study the hand and try to sort of re-engineer it, a lot of times there's this big debate going on. Okay, do we really need to have 5 fingers? Can we get by with 4? Can we get by with 3? In some cases, you can see the companies were wrestling with that. And I think they all sort of settled, we're going to go with the 5 fingers, but we're going to drop a knuckle. Now, I've noticed that you kept the same number of knuckles in there, and you have the sensors on the tips. I don't know. I guess you don't have the sensors in the middle. Do you see that just in the tips is kind of where they're needed? And as far as how dexterous it is, I see you can grasp, but can you do this? Can you do live long and prosper?
We actually can do that. Yes, it does have that adduction. Yeah. Yeah.
Okay. Incredible. Incredible. So that means you can play the piano.
Yeah. In fact, we'd actually just been debating this earlier this week, giving you some insider baseball here about how important this degree of freedom is. So there's some debate on the engineering team as to whether we actually need this degree of freedom or not. Some people believe it's absolutely critical, and some people believe you can get away with something that's just kind of more like this without the fingers moving. So being an experimental scientist, I'm always like, well, let's try it. Let's do 1,000 different tasks under teleoperation with the robot hand we have, because we have a hand that can do mostly all the movements the human hand can. So what we're doing currently is running an experiment where we try it with all degrees of freedom engaged or allowed, and then we lock them. And then we say, okay, let's now do experimental results on all those tasks with this degree of freedom locked. Because if you have a super complex hand, you can always lock the degrees of freedom and make it simpler. So for us, instead of sitting around arguing about it, I'm like, get in the lab, do an experiment. Cool. Let's prove it. And then if engineer number 1 can prove that the tasks, it makes no difference, then we'll be like, okay, well, we don't need that degree of freedom. Let's remove it.
Okay, that's interesting. And I'm going to ask you a question that I was going to save towards the middle, but I'm going to ask you now. This is what I plan on asking everyone who is in charge of the technology at a humanoid bot company. And that is, if you were able to add 1 extra degree of freedom to your bot and it came completely free, no consequences whatsoever, no cost, no weight, absolutely no penalty, which joint would you add that you wish that you didn't have right now?
Well, I'd probably add more hips so it can dance. No.
Okay. Now I'm going to, so which one is that? It's going to be somewhere down in the torso, lower torso.
Yeah.
Right?
Yeah.
Okay.
No, I'm actually just kidding. Although I'm kind of half kidding, right? Because I think it's really important for us to build a good working relationship and good social relationships with the technologies we're building. It's all about this human-robot interaction factor. So just something like a robot being able to like dance or something like that it makes it more human. It makes it more cool. But if I was going to add a degree of freedom that I think would be, useful for work, it would probably be this shoulder one. So your shoulders actually
scapula.
Move. Yeah, they move backwards and forwards.
Exactly, and that's
it
been
gives
pointed
you
out.
Extended reach. Yeah.
Yes, and I know a couple of biomechanics, and they point that out as well, because it basically makes your arm almost like an 8 degree of freedom arm by doing that.
Yeah,
because
and
I've noticed.
Sorry.
You have a lot of degrees of freedom already in the torso, more than others. So like your hips, you actually have 3 degrees of freedom right in the torso, not in the legs itself. I mean, that's another one. So now I'm going to turn the script around and say, it's too costly, too much weight. We've got to take a degree of freedom out. Which one do you cut out?
That's very interesting. I mean, there is a degree of freedom that I'm particularly partial to, which is the head tilt, or I guess it's roll.
Yes.
I like it because it gives the robot a lot of character and ability to convey emotions. And that one might have to go if the robot is just, working in isolation on its own in the back of a warehouse. Poor thing.
I agree. It's like, if you look at it, it's one you almost don't need, but I've joked that without it, it can't play soccer because you can't do a proper header. So if you want to be general purpose, it's got to stay in there. Okay.
Exactly. And actually, when we bring a lot of visitors around to the lab, and when you interact with the robot and it's in teleoperation mode, and a person kind of like just looks at you and tilts their head to the side, it instantly evokes this kind of like funny, humorous, joyous reaction. So yeah, we need to absolutely build technologies that can interact with people in a way that they don't find scary, but they actually find engaging, and people want to interact with the robots.
Now I have another theory here, which is kind of tying into teleoperation, is that if you take away some of those degrees of freedom, it makes it a bit harder to teleoperate. And we noticed that in another company is doing that, didn't have it in the head, and the operator was moving the head and it wasn't there. And we suspect that might be why at least a couple degrees of freedom were put in there, partly for like socialization reasons, like you're saying, and also because the operator is constantly doing that, and you're giving conflicting signals to your data set on what the motions are. So in some ways, it does make sense to try to simulate everything as much as possible. So when we go to teleoperation, I know Herbert's going to have a couple of follow-up questions on it, but my first one is like the exosuit you have means you've got haptic feedback, because if you do it with your normal kind of, Oculus Vive handset, sometimes you don't get that subtle haptic feedback to know what it's really like grabbing that bottle. So I assume you have something that when you try to clench and suddenly you get a reaction force on there, does the operator feel that and really get a good sense of what it's like to pick that thing up?
Yeah, they do. So on our teleoperation rig, like quite a few of the pieces are like off the shelf available parts you can buy. We use the Haptex gloves as the haptic glove feedback system. So I don't know if your audience are familiar with these gloves. It's from a company called Haptex. And they are basically state-of-the-art haptic gloves that you can buy. They're incredibly expensive. You'd have to be a really serious VR gamer to want to purchase a pair of these gloves. But for what we do, it's absolutely critical. So these gloves have both force feedback on the fingers and haptic feedback. So what that means is if the robot grabs an object, the pilot's hand is actually stopped. So the pilot's hand kind of just looks like that. Great. And they're not able to move it. So they feel the object, they feel the force from the object, and then they also feel the pressure coming from the haptic sensors on the object as well. So these, very, very state-of-the-art haptic sensing. And we've actually done a couple of cool experiments where we've put an object down in front of the robot on the table, and the pilots either had to look away or we've turned off their vision system, and they have to kind of feel around until they find the object and then grab it. And that's actually working, which is really cool.
Oh, wow. That's interesting. Now, you kind of touched on one thing. You talked about like an off-the-shelf component that you're using for that. When it goes to the actuators, are you using off-the-shelf or are they bespoke?
The actuator packaging and housing is designed in-house. So the individual parts, like the gearboxes and the motors, are purchased, but they're actually the packaging is designed and assembled in-house.
Okay. So you do have a supply chain for some of those critical components.
Right. And again, from our perspective, the robot is really a means to an end. So, we don't mind buying other people's parts. Even I can give you a little bit of like juicy information if you're interested. Is that we're actually planning in the future, in the very near future. I can't give you the details, but we're going multi-embodiment. So we want to be able to support a little bit of hardware. So I can't give too much away about this yet, but maybe a little bit of info there. Our in-house Phoenix robot, as I mentioned, we designed and built it because at the time when we started several years ago, there was nothing. There was no general purpose humanoid you could just go to Walmart and buy, right? So we absolutely had to build and design our own from scratch. And the other reason we wanted to do that is we own the full control stack. So we can control that robot right down to the currents and voltages in the motor drivers. So it's absolutely great. But it is an expensive prototype system, and we're not precious about it being our robot that the AI gets to control. We want the AI to control lots of different hardware systems. So I can see in the future there being room for multi-embodiment AI platforms that control not just Phoenix robots, but other kinds of robots and even other kinds of machines. Okay,
because that'll be interesting, as you're sort of touching on. If you don't have the right hardware design, the AI won't be able to learn quite enough. So like you say, there's that catch-22. You don't know when you've got it right. Yeah. You're working on making things that are simulatable. And having spent the last 4 decades trying to simulate industrial robots, I can tell you there are a lot of them out there that don't feel to me like they're simulatable. Others that are a lot
Absolutely.
easier.
It's a huge problem. It's actually a huge problem because if you're trying to build a super complicated robot with 70 degrees of freedom, simulating it is often very, very hard.
Right. It's because like you say, you have to get it down really to the control systems, because that's everything the AI is doing. It has to understand when that current goes in there, this is the reaction everything's going to have within the world. You've got to have real world physics in there and everything. Otherwise, your only choice is you got to build 1,000 bots. And I agree.
That's
you
right.
need to bootstrap it somehow by getting those millions and millions of iterations that when you even decide to go to 1,000 bots, you have something that's ready. Otherwise, it's going to be hard to even get anything out of them. I want to touch on one other thing, and that is when you've been talking about visual servoing, you have like this idea of what I call sensor fusion. And I know this was like a problem that Tesla had because they basically were taking on the FSD, their vision system and their radar system were conflicting because basically they were both kind of the same thing. They were both vision systems. Whereas your vision system and your tactile systems, they're really distinctly different. And now you're not talking about trying to reconcile conflicting information. You're talking about complementary information. Mm-hmm. And are you seeing that by bringing that in, your AI systems are actually able to train or learn a bit more quickly because they have more information about the world rather than a very narrow picture of the world?
Yeah. So again, super interesting. I'd call that an open research question. So sensor fusion's been something that's been explored in research environments, but not really in full humanoid robots yet. So our hypothesis is always the human brain seems to be able to do this very well. So, excuse me. So maybe AI systems should be designed in that same way to mimic the way that the human brain does it. But no one has really been able to show this yet. So no one has really been able to show vision and haptic data being sensor fused using modern machine learning approaches. So most of the modern approaches now use some variant of these transformer networks. There's like action chunking transformer and diffusion models, diffusion policies and things like that. But no one's really created these foundational models for haptics, foundational models for vision, and then shown them coming together into something that controls a whole humanoid robot. The RTX work from Google is probably the closest to showing that kind of thing. But it's still an absolutely open research area. So we don't even really know it's possible, but we know that the human brain does it. So that's...
Are you expecting emergent behavior once you do that?
I mean, I would expect so, yeah. I think we saw emergent behavior in large language models that we weren't expecting. Yeah. I think when the data set gets big enough, you will start to see really interesting emergent behavior.
Okay, so Suzanne, we've talked about how the humanoid bot is just a means to an end. You guys are working on the brain in the mind. You talked about carbon, which is mimicking memory, sight, sound, touch, and everything we just talked about. Now you... and Jordi, the CEO, you guys came from D-Wave, and D-Wave was the first commercial quantum computing company. There must be a link, right? If I connect the two together, quantum computing, and I've been studying physics and astrophysics and all that stuff about the brain, and there's belief that the brain, the reason I'm conscious is because my brain is quantum. That's not proven. That's a possibility. Can you speak a little bit about that? Is there some connection between the quantum computing, the company you came from, now you're working at the humanoid bot? What is that connection?
It's actually so interesting that you mentioned that, because for the past few months, I've been pretty much obsessed with this idea of quantum consciousness.
Okay, that I didn't want to say the word consciousness. You did it. Mm-hmm, okay, because I was going to say it. I love it.
Yeah,
okay.
I broke myself into jail here, but so I was brought up and formally trained as a very materialist, sort of atheist, scientist type person, and I never believed that you would need something special to make consciousness happen in a system. I thought, it'll just emerge from AI techniques, but I don't actually believe that now. I think that there is something really interesting going on with consciousness, especially given some of the recent results and research that's being done. Now, again, I'm very open-minded. I'm not saying we need a quantum computer or we don't need a quantum computer, but in the case that we do, I know where to get one. And I'm very interested in going back to some of those quantum algorithms I worked on in the early days and maybe combining those together with AI models to create some kind of new computing resource inside AI that may or may not be the source of conscious awareness. So a lot of this is very speculative, but I find it absolutely fascinating. We absolutely do not understand what consciousness is. And if we want our AIs to have it, or at least we want to give them the option of having it or not, then we should be researching this. And if it requires quantum computers, we should be researching that too.
Okay, what are you guys doing in terms of alignment with human values? This is getting, you referred, or I caught you a little earlier. You said, "Oh, poor thing, going to be working all by itself."
Yeah.
You feel attachment to this, and you think that they're a self. What's going to happen when how do you as one leading humanoid robot company out there, how are you looking at this?
Yeah, so I know you mentioned the mother of AGI comment in your thing, but I do honestly, some people might think it's weird, but I do think of these systems kind of like my children. The reason we called the company Sanctuary is we wanted a place where AI could develop and learn from us and learn about our values in a kind of safe bubble before it gets sent out there in the world or it gets unleashed on the internet of data or something like that, right? So I want to introduce the AI slowly into the world by using training examples from teleoperation from people. So remember, if you're running a behavior cloning algorithm or an imitation learning algorithm, everything that AI is learning comes from people. So this is a cool fact about these new style of training, is that all the data comes directly from people. And we get to, as a company and as a wider society, which is why I mentioned consortiums and collaborations, we get to choose where that data comes from. Sorry. We get to choose where those data come from. So it's up to us to train the AIs using data that we think is appropriate and correct, and embedded in those data will be our values. So even something as simple as picking up a cylinder and placing it on a target being done in a human-like way, maybe there's some tiny amount of human value embedded in that. Like we mentioned, the way the humanoid robot interacts with someone when it meets them and talks to them, that is all going into the training data. So I think that human values can be learned from humans. I don't think we should attempt to program them in. I think in a way, the analogy of them being our children is a very good one, because they're learning from us. They're learning from demonstration. They're learning from watching us. And I think that will ensure that they learn to do the right things in the right ways to fit into society and to help society and to even go beyond us. So we want our children to learn from us, but to then go beyond us and become better than us in some way. So I'm very much an optimist, but I see that as being the future of AI. I see it as being radically aligned with human values, radically contributive to society, and helping us grow as a civilization, helping us not just here on Earth, but be able to go out there into the stars, taking our values forward into the future as the next phase of civilization. That's my vision for where this is going.
Yeah, very much a utopian future. On the way there, though, right, there's going to be tremendous disruption. What's going to happen to the displaced workers? I know earlier you said that initially the robots there's so many jobs that are open, that there's jobs that are available right now that people don't want. So that's going to be fine. But eventually it's going to displace human workers. How can we prevent that from being so disruptive and putting a lot of people out of work?
I think there has to be phases. So the initial phase, I think, as you mentioned, will be addressing job shortages. So that's kind of like phase one. And that in itself is quite a long phase. I can see that going from now until at least 2030. Because as I mentioned, I think around 2030, we'll be getting up into the millions. There are way more than 1 million job positions unfilled, open in dull, dirty, dangerous environments that these systems could tackle. Now, when you start to get into the billions, Now there's an interesting question. But I think we're going to have enough time at that point for governments to start thinking about what's really going on here for their populations. And I don't think it's just going to come from robotics and automation. I think many technologies are going to change the way we live and the way we work over the next couple of decades. And also, if you look at the data coming from birth rates and fertility rates, there's some really worrying demographic trends going on. So something like aging population, caring for an aging population is a huge problem. There not being enough young people to support the economy in, say, 20 to 30 years' time. So I think it's a little naive to just think about things today like, oh, there are a certain number of jobs and then robots will take them. There are massive macroeconomic trends that are going to change everything about the global economy over the next few decades. So I think it's really going to be really hard to predict the future. So the thing I see about robots, so this is kind of like the punchline here. We have optionality. We now have a new technology that, if we wish it to, will provide labor at low cost. But it's a wider question of how do we adopt that? How do governments structure things so that optionality for that new technology is used wisely, and so that we actually gain as a society and as a civilization, and we don't lose out here.
Mm-hmm. Scott, did you want to ask another question?
I've got tons of questions here to go through. This has been a very interesting conversation, and of course, we're thinking of everything from how the bots are actually going to be built to, like we say, these wider societal questions. And I agree with you that kind of looking at the rates that we think. This is based on a lot of work that CERN Basher has done, kind of coming up with sort of the same numbers you use, like around 2030, you start to get to those millions. And that's really not going to be displacing any workers anytime soon. So now is when we need to start having a dialogue, because my concern is that when that point comes, the governments are going to just start making decisions and the policymakers will be completely uninformed. And so now it's incumbent upon us to start having these conversations and having the conversations with all the stakeholders that are out there, and not have it suddenly be a couple people, just by fiat that this is what it's going to be. So it seems like you have been pondering that question as well, because it's something I've been pondering, Herbert is pondering, and surprisingly, I guess I should say unsurprisingly, most of our viewers also do that as too. When you read the comments and stuff like that, they are having the same thing. And I really hope we're able to keep it opened up as like a very frank discussion, because it could clearly get very emotional very quickly. And I do agree, it comes down to unfulfilled jobs right now nobody wants to do, that are definitely dull and dangerous. And there's still others that people are doing that very soon they won't want to do. They are safe, but they're more or less is what they have to do to get a paycheck. They would like to see something a bit more fulfilling. And again, the bots will be able to do that. So hopefully it means not just an age of abundance, but an age of fulfillment for millions and billions of people.
Yeah, that's right. And I like to think, again, just coming back to this idea of these robot systems being able to do jobs that either don't exist yet or can't exist yet for some economic reason. So one dream I've always had is our ability to do science and have new scientific breakthroughs, especially in medicine and biomedicine, is like kind of limited by the number of scientists and researchers that we can train. So imagine you could have an AI robot system on demand that its mind could just be a software system that knows everything about all the latest biomedical research. And you could build, say, a new warehouse facility that was kind of like a wet lab or a chemistry lab, and it was just running experiments 24/7. This can't exist today because we do not have those people trained up to do those experiments. And you can't do it with digital AI because you literally need robots to actually go in there and do the experiments and discover the cure for cancer or whatever. So I know it's utopian and optimistic, but I try and think about what we might gain that we can't even imagine today by having these systems being able to work on demand 24/7 at low cost. Let's put them to work doing things that we just can't do today, like solving unsolved scientific problems, finding cures for diseases. We're like, oh, wouldn't we love to have, another 10,000 top research scientists working on a cure for cancer? Oh, we can't. Well, maybe we can with this technology. So right. I know that it's maybe some people say, oh, it's like Pollyannish to think like that. But I think having a little bit of that hope and optimism can sometimes offset a lot of the worry that's also out there.
Yeah, it opens it up for more people that now will have that opportunity, because they don't necessarily have to worry about how they make ends meet. Now I have the ability to actually go and pursue a lot of the passions, and those passions could be in medicine and science and in the arts in a variety of areas. There was, I think, one thing that I was going to touch on. You're talking about them being children. And of course, the thing is that when children grow up, sometimes they learn new tricks that we hadn't taught them, because that's part of being human. And do you think that if we're going to be teaching the bot the same way to grab the can again and again, at some point, you're pretty sure it's going to come up with a more clever way? Because I've seen it at times where we do things a certain way and someone else finds a trick, and unfortunately that trick doesn't make it in the database. And I just remember this at a Trader Joe's about a year ago, watching the cashier bagging everything in a particular way with a motion I had never seen, that I said, whoa, no metacarpal. I mean, and it was quick and efficient. And I was like, I wish I had got my camera out and filmed it, because it was like, that should be in the training set. But unfortunately not. Do you think the bot will be able to recreate whatever that was, even though it's not in the training set?
I think so, yeah. So there's kind of two main ways you can train these systems. One is using this imitation way, where you're just learning from demonstrations you've seen before, but you can also use a reinforcement learning. So that's kind of like, what the outcome you want, but you don't quite know how to get there. And the machine learning algorithm just tries a whole bunch of different options that some of them might be completely not work, but there might be one that does it, like the kind of weird grocery bagging thing you were describing. And the cool thing about that is, once the technology is running fast enough, those reinforcement learning experiments can be done inside the AI's mind.
Exactly.
So it can kind of on the fly go through a million different options that it could try, find one, and then actually execute.
I call that the Doctor Strange mode. If you remember from the Marvel, where he sits there and looks at every possible combination. It's like, oh, that's the one we've got to do.
And if you had a quantum computer, you could do them all.
Oh yeah,
at the same time.
Yes, you could have, because we do that already. When you ask me to do a particular task, I already simulate it in my brain.
Yeah,
I know what it's going to feel like, and if for some reason, as I execute it, it doesn't quite feel the way I was simulating it, then I know there's something wrong with my assumptions. And of course, the bot must be doing the same thing, thinking ahead what the task is, what its expectations are, and if suddenly the currents are like way out of alignment, it's like, wait a minute, something's going on here. We must be hitting an obstruction. Maybe my elbow bumped something I didn't notice there, and that's causing a problem.
Okay, so Suzanne, this is fantastic. I love everything we're talking about. So I want to come back to Sanctuary. Where are you at now? What's coming next? So a couple of questions, right? There's a partnership with NVIDIA that you can maybe talk about. They announced their Isaac at the latest CES conference. You guys were mentioned, to take advantage of that. And then two, are you raising money? How's your funding going, and how much do you think you'll need, and when are you going to go back out to ask for more money?
Yeah, so on the simulation side, we work closely together with the NVIDIA. We use their tools, and really, I mentioned the simulation before. So we're fast tracking the amount of data you can get. So if I had to summarize our 2024 plan in a single word, it would be data. We are trying to collect as much data as is humanly or robotly possible, and simulation is an absolutely huge part of that. So we're really doubling down on simulation, on teleoperation in simulation, to gather a very large number of training examples to do algorithm and model development. And then that will then help us with closing this sim to real gap as well. So one of the things we're working very closely with NVIDIA on is on, can the physics simulation, can we make physics in the simulation better, so that when you actually running it on the real robot, it transfers, and the AI policy you've trained in simulation just works. that's called zero-shot transfer learning, and it's kind of the holy grail of AI, because then you can do all the model training in simulation. So yeah, that's very promising. But you do need a lot of data to do that kind of thing. On the fundraising side of things, I can't really say too much on that at the moment, but I do believe you might be hearing something very soon about that side of things.
Okay, wonderful. Thank you so much, Suzanne. This was a fun conversation. It's again, very unique that your background, specifically your expertise, is coming in from the mind first, the brain first, and then you're focusing on the hands first next. And then that's your approach. It's very unique in the industry, your willingness to partner, the humanoid form, or probably even other forms. It doesn't really matter to you. It sounds like it's just more about, getting embodied AI to get out there first. You're a very exciting company. I think we need to keep a close eye on you guys, and appreciate your time to speak to Scott and me today.
Yeah, well, thanks very much. This has been really awesome. And if anyone's still worried about robots, do not be. We're going to be raising them very, very safely and making sure that they do the best that they can for us as humans.
And thank you for Suzanne. This is a very fun conversation. I enjoyed it, and hopefully it's just the first of many.
Thanks very much.
I've created a website that is the most comprehensive resource for the Tesla investor. Please check it out. Simply go to my website at herbertong.com.